exactly the same as something else. Okay, it can be drawn in a different place, but it has to be exactly the same size and shape as it. Okay, all the angles have to be the same. Everything has to be the same. Now, similar figures are enlargements of one another. Okay, so at this point, remember we talked about enlargements. Enlargements don't have to be bigger; they can be smaller as well. So enlargements can be smaller or bigger than each other. Okay, so these would all be similar figures. Similar figures have the same angles. It's just the lengths that are different. Okay. Most common shape we see when we're talking about similar figures is the triangle. Okay, you may be asked to find missing angles or lengths. Okay, we've got these two triangles here. The angles are the same. Okay, so we've got the red, the blue are matching, the purple are matching, which means the red are also matching. Okay. In some cases, they may be drawn like this. So these are the most common type shapes or the way they show them in a question. Why would these two angles here be similar? Try and not look at your notes if you wrote it. Why would those two angles? How do we describe those angles? Knowing that these two lines here are parallel. Only one person. Did you look at is this written in your notes? Agree?
It's because the top part is like the smaller version of like the big triangle.
It is, but why? What these are special types of angles. What kind of angles are they, Jamie?
Corresponding.
They're corresponding. These are corresponding angles. Do you remember this from like probably year 7? Mm-hmm. Okay, you do need to remember it for your GCSE, so you do need to be able to remember the corresponding angles. So corresponding angles are relating to the parallel lines. Okay, so if we have two parallel lines here, then we can see that these two angles are sitting on top of those parallel lines, therefore they would be equal to each other. Obviously the same would be for these. Okay, so they're also corresponding. And then obviously this angle here for both the small and the big. Can you all see the small and the big? Yeah, so this would be the small, and then you've got your big here. Okay, so obviously they would be your three angles being the same. If they're drawn like this, again, these are parallel lines. This angle here would be the same as which word?
Anyone from the bottom?
The bottom right. Good. And what kind of angles are they? Remember having had a bit perhaps a hint with the corresponding?
Are they adjacent?
No.
Oh.
But right there, sir. Near?
Alternate.
Alternate, yeah. So they are alternate angles. I don't know how you want to remember it. I remember because they kind of make a Z shape, and it's A to Z, like the alphabet, A to Z. And then I have weird ways to remember things. Obviously, these are also alternates. And then these are the other two angles. What kind of angles are they? Only 4 people remember their angles now. 3?
Vertically opposite.
Vertically opposite, lovely. And it's always weird if you say, why is it vertically, why is it not just opposite? I don't know, they just ask you vertically opposite angles. Okay, so all of those different types of angles are equal to each other.
But if you
Yes. That's what I mean, that's why it's like, why are they vertically opposite? I don't know. There's just a thing. Okay? In these cases, much better to be small shapes. Yeah, so if you have this kind of situation, I would definitely recommend that you just wrote the two triangles next to each other. It's a sketch, it should take you 2 seconds. It just enables you to label the lengths that you have. And as long as you're drawing them in the same orientation, it's going to be a lot easier. Okay, especially when it comes to these ones, because obviously they're upside down. And people start thinking that these two lengths will be equal, when in fact it will be these two lengths that will be equal. Okay, so I would suggest just draw a little sketch next to it with and label all of your values on there. Which of these triangles are similar? When you're doing this kind of thing, often it would be a process of elimination. So we've got a 3, a 6, and a 4. Anyone want to suggest what they would do? Emily, do you have any recollection? What would you do with this? No? Just Leona and Jamie? Elena?
Pardon?
Any suggestion how we would decide if they're similar?
Well, I was looking at my notes. Basically, compare the length of the side.
Yeah, exactly. Because we've said that similar shapes are bigger or smaller. So that what's happened is that all of your side lengths are multiplied by the same number. But it has to be all of your side lengths are multiplied by exactly the same number, not almost the same number. It has to be exactly. So you would choose one of the sides. Now, if I was doing this question, I would select the largest side, probably. Okay, so I would try to be comparing these lengths here. Okay, so I would start off by comparing triangle 1 and 2. So if I were to do 18 divided by 6, what would that give me? 3. So I'm thinking that this shape here might be 3 times bigger than this one here. So then you have a look and check about the other lengths. So my smallest length would be 3. 3 multiplied by 3 is 9. Do I have a 9 anywhere on here?
No.
Okay, so that eliminates these two triangles being similar. Yes? Does that make sense? Alright, so let's look at the triangle 1 and 3. So from 6 to 9, what would be my scale factor? How do you find the scale factor? Divide. So you're going to have 9 over 6, which comes to 3 over 2 or 1.5. Okay? So we're trying to decide, are they 1.5 times bigger? So check the smallest length. What's 3 multiplied by 1.5? 4.5. Okay, looking good. And our final check is 4. 4 multiplied by 1.5 does give you 6. So therefore, triangle 1 and 3 are similar. You want to look at that? Oh, that's pretty squashy, isn't it?
I just got back to this before, but it's like that kind of thing. Would that be asked on the exam? Like, when they say, are these two triangles the same?
Yeah.
Like, show that.
It could be, yes. It could be show that they're similar, or are they similar? More likely it's going to be the kinds of questions that come up in a minute, to be honest. But this is a good lead into it, yeah. So if they are similar, all the properties and angles are going to be the same. So we would have 3 measurements, 3 angles that are exactly the same. So how do you find a missing angle if we know 2 of them? Everyone's hand should be up here. Emma.
You would add up those two values and half it for 1.
Perfect. All right. So 60 plus 55 is,
114.
and then 180, subtract that. Yeah. All right. So this angle here is 65. So we've got a 60, 65, and 55. Are triangle 1 and 2 similar? No, because already I've got 60 in it, but I haven't got a 65. So 65 and 60, so I know it's not those two. And 65 and 60, what's my missing angle? 55, so obviously 1 and 3 are similar there. Okay? Alright, so if you're talking 2 sides and then do the angle, the ratio of the sides is the same and the angle is the same. Alright, similar shapes. So we've got here, are these triangles similar? So we would say, again, we would compare our measurements. So we would say 11 over 6 would have to be the same as 9 over 4. Is 11 over 6 equal to 9 over 4? Well, what's 11 divided by 6? 1.83 recurring. And 9 over 4. Okay, so they are not equal, therefore not similar. Okay. We're told that these are similar. find length of x and y and angle w. I'd suggest angle w is the easiest thing to find first. What would angle w be? 51, 50, Gabriel.
We are corresponding.
Yeah, you can say that. They are corresponding to each other. Yeah, they're equal in value because they're similar triangles. Okay? If we then are trying to find length x, start with, let's use the length, that's it. Always start with the length you're trying to find. So I would have length x. What would I divide length x by? 7. And that would be equal to what? Now we need, in order to be able to calculate these things, we need to have two corresponding lengths that are marked. Alright?
6 over 8.
Good. 6 over 8. And we all happy with the order of that it's not 8 over 6.
No.
Okay, because we started with this triangle here, and therefore we start with this triangle length on the top here. Alright? So we've got then x is equal to 6 over 8 multiplied by 7, just normally rearranging, which gives us 42.8.
Oh, over 8.
42 over 8. Oh, you just did that.
Oh, which is
That.
5.1.
5.1? Thanks. And we need to find length y. So length y would be divided by Dinah.
4.
And that would be equal to what?
8 over 6.
Okay, why did we start with 8 this time? Good, that's right. Perfect. Alright, so then y is equal to 8 over 6 multiplied by 4, which is 16 over 3. And given that x, you're quite fast, Casey, are we good with this? Okay, so essentially, oh, thanks, Brianna, I forgot that one. Essentially, each of these, it's like you're just going in ratios. So one corresponding length must be equal to the other ratio. Okay. So see if you can do this one for me then. So we've got two triangles. We've been told they are similar. So we're trying to find x. So I would start with x. What would we divide x by?
X over...
Which
over 4.
yes. Would be equal to, bless you. Say again? Yes. Always make sure you're starting with the same triangle. Yeah? And therefore x would be 6 over 3 multiplied by 4. Well, we know that 6 over 3 is 2. 2 multiplied by 4 is 8. Alright, so this one's not a triangle, but the rules are still the same. Brianna, how would I do this though?
We put X over 8.
Lovely.
Equals 3 over 5.
Lovely jubbly. And so that's 3 over 5 multiplied by 8, which is 4.3. Thank you. Shayla.
X over 5 equals 7 over 4. And then X equals 7 over 4.
Nice. Which is anyone? Pardon?
8.7.
Yeah. Okay, diagram shows the 2 meter wide path around 12 by 8 swimming pool. Are the two rectangles similar? Justify your answer. So this is more like the kind of question, Jamie, that would come up in that it's making you actually think about stuff. What would make something similar? So if we know that this is 12 and this is 8 and this is a 2 meter wide path, let's draw our two rectangles. So this is 12 and 8. Our bigger rectangle would be what measurement along the bottom?
16.
Yes, be careful. Remember the path is 2 meters wide all the way round. So all of these are 2 meters, which means that you're going to have 2 here and here, which makes it 16. Yes?
Yeah.
And then this measurement here would be 12. So we have to decide if they are similar. So we would say, is 12 over 8 equal to 16 over 12? Is it?
Yeah.
What's 12 over 8? Do it on a calc. 1.5? What's 16 over 12? 1.3. Okay, so are they similar?
No.
They're not equal, so therefore not. Right, show that the figures, following figures possess similar triangles. And so we would show our two triangles with our labels on our vertices. So this first one is BBC. What would our big triangle be? C, E. Okay, and there's our right angle. Now, for this diagram here, it may be worth just kind of showing that's there. We've got two triangles. What's my top point going to be labelled for both of them? C. Nice. So sometimes it's easier to work this way. So if I focus on this one here first of all, so if I have A here, that means that this is 40, which means that this is letter D. Do you want to do that?
Yeah.
And if I'm showing them in a similar way, my 40-degree angle is labelled what letter? D. And then therefore this one would be E. This is supposed to be a B, Miss Harrison. Okay, somewhere over it. And then this is E. You want to do that? This baby here, we've got two triangles. Did I draw them the right way up or upside down? Did we do this? Oh, we did draw them. Okay, let's draw it. Well, that's quite nice. Okay, so should we start with big or small? It doesn't matter.
Small.
Small. Okay, so this one's going to be R. So my two other letters are what?
S and then
That's so cute. Three.
no.
Okay? So, which angle is corresponding or equal to the S angle? The T, yes? You happy with that? So therefore this vertex here must be labelled T, because that's the one corresponding to it. We do R as the top for both of them, which the process of elimination means this is P. It would definitely look quite quickly, but I'm hoping you're okay with it. Give that to me now. And again, two triangles. Oh, not really much. I've not room to measure. What's my top vertex for both of them labelled? B. So let's write the bottom one as X and W. And so this is my 24. So my other 24 angle would be here, because it's the same place, so that's Y, and the other one is U. Okay?